Section 9.8 has us working with rational exponents. And what this means in practice is that we are now going to have exponents that have fractions in them. So this means all of the previous rules that we've learned for adding, subtracting, multiplying, dividing, and simplifying fractions are all still in place here. We do need to remember those because all of those are going to be coming back in problems that we are going to be seeing and working through. It should also be stated that, as a refresher and a reminder with this, because we are working with exponents, we need to make sure that we are correctly identifying the base of each exponent before we actually apply that exponent to the problem. So the main difference that we have with this is the difference between having negative 2 to the second power versus the quantity of negative 2 raised to the second power. In this first example, the negative is not included in the calculation with the exponent. In the second example, that negative is included in that calculation because it's contained inside a set of parentheses. That subtle kind of difference is something that we absolutely need to keep track of as we are going through and seeing some problems in this section. So as a reminder, we have some rules and properties for exponents. Now I'd recommend pausing the video here and writing all of these down for yourself if you need to, because we are going to see all of these show up. The pages that are listed here are for the textbook that we are using, but the properties and the rules that we have are pretty universal, so it shouldn't matter which textbook you are using, all of these are still applicable. Now the main three that I recommend that we make a note of for ourselves is the product rule, product to a power rule I should say, the zero exponent property, and the negative exponent property. The product to a power rule states that if I have two things that are multiplying together inside a set of parentheses and they are raised to a power, then each of those things inside the set of parentheses are individually being raised to that power as well. It should be stated, as it says in the name, but I'm trying to emphasize this, this only works if I have a product that is raised to a power. This does not work if there is two things inside here, let's say A and B, and they are adding or subtracting together. This rule does not work if I have two things adding together or subtracting together. Otherwise, we can't use this at all. A lot of people attempt to do that, and it gets them in trouble, and we get wrong answers from there. Now, the zero exponent property states that if I have a non-zero base, meaning any number other than 0, raised to the 0 power, then the answer is always going to be 1. So if this base is a positive, a negative, a fraction, or a decimal, and it's raised to the 0 power, the answer is always going to be 1. Now the last one that we have here, the negative exponent, this is one that gets a lot of people in trouble because we incorrectly identify and use this negative sign in the exponent spot. So what the negative exponent states that if an exponent is negative, then we take the reciprocal of the base. We make the exponent positive and then simplify the resulting expression afterwards. So what this means is this negative in the exponent spot absolutely never changes the base from a positive to a negative number or a negative number into a positive number. All it does is it says, where is the base in this fraction? In this case, what we have here, this a is implied to be over 1. So with the negative exponent, I take the reciprocal of the base, meaning I move this a from the numerator of the fraction into the denominator of a fraction. Once I do that, I make the exponent positive, like we have here, and then I would simplify the resulting expression down as necessary. In this first example, we don't need to do anything after we have moved the a to the b power into the denominator spot. In our second quick example that we have here, I'm starting with this negative exponent in the denominator of a fraction. So the negative says, take this whole term that we have here, and I'm going to move it to the numerator part of that fraction, and that's going to just become a to the b power. Now it should be stated again make sure you are correctly identifying the base of an exponent. If I have multiple things that are multiplying together, but one is raised to a negative power and one is raised to a positive power, make sure you are correctly identifying which one gets the negative exponent, which one would get the positive exponent. If we get those mixed up, there's a lot of room for error with that. So let's take a look then at our more specific information as it pertains to rational exponents, or really exponents that are fractions. So we have two main things we need to note with this. Again, I would recommend pausing the video at any time to write these things down for yourself as we're going through them. So if I have a base raised to a fraction exponent, the numerator of that fraction says that I'm going to be raising that base to that power. In this case, we're using m over n as our fraction, so the numerator, being m, tells me I'm going to raise the base to the m power. The denominator says I'm going to take the nth root of that base. You can also think of that n as the index of the radical that we're working with. So again, using our example of m over n as the exponent, it means I'm going to take the nth root of whatever this base is. So I want to make sure we have that clear for ourselves. The numerator, being above, raises something up to a power. The denominator, being down below, it's going to drop the value down because it's going to be taking the nth root of something. So the numerator is going to make the number bigger, the denominator is going to make the number smaller. Just make sure that we are correctly identifying one is raising it to a power, one is taking a root of it. Now, when we are going through and actually determining what our answers are going to be, if we have something raised to a rational exponent, I think it's very, very, very useful to rewrite all of those things down, or rewrite those down into one of the different forms that we have below. All of these are equivalent ways of writing out something raised to a rational exponent. It's your choice as you are going through the problem to determine which one is going to be more useful to you. Now, within these four, I think the two main ones that are worth using are the two bottom ones here, but nothing says you can't use the two up top as well. So really, again, it's your choice on which of the four you want to use, but feel comfortable with identifying the exponent and the index of the radical and rewriting them as necessary. Maybe you have something starting in this form here, and you want to rewrite it into the form that we have up here. Nothing says you can't do that, and you are welcome to do so, if that would make the numbers and the problem easier for you. It should be noted as well when you're doing this, make sure you're doing that rewriting based on the situation and the numbers in the problem. Rarely, if ever, is there a situation where you always want to write it into this form, or always write it into this form that we have here. I've never come across a really concrete way of saying this method is always going to be better first or second. It's very much dependent on the information that you have been given. And last but not least with this, when we have expressions where we have rational exponents showing up, we are going to use PEMDAS and the order of operations to go through and simplify these things down. Now, when you are working with the exponents themselves, really, it's kind of your call on which of these properties, which of these properties and rules that we have that we want to follow as we're going through them. This includes all of those properties that we have up here having rational exponents showing up within them as well. Personally, when I go through these problems, I generally like to look for and work with the negative exponents first. I think those are the most confusing for me, and so I like to get rid of those right from the very beginning and make sure I'm putting everything in the right places ahead of time. Now again, that's my personal preference. You do not need to do that. You could use any of those as you are starting a problem, and then use a different one as you are going through it and as the numbers kind of bear themselves out. So let's take a look at some examples that we have listed down here. So again, it should be noted before we dive into these, all of the values and variables that we have are restricted to be positive real values as we're going through them. Looking at example 1, we are going to remember that our numerator tells us that we are going to raise the base, which is 16, to the first power, and the denominator of that fraction, the exponent, tells us I'm going to take the fourth root of the base as well. So it's now our choice on which of the 4 different ways of rewriting this thing that we would like to use. If you took a screenshot or wrote those down in that kind of boxed order that they were given to you in, we are going to use the one in the bottom right corner to rewrite this thing. Now the reason I'm selecting this is because I'm thinking ahead and I'm saying, well, I'm going to have 16 raised to a power. Well, anything raised to the first power, like we have right here, is just going to be itself. So it's not really going to change. So really, I'm just going to have the fourth root of 16 showing up in here. Okay? Pretty easy to take care of. The numerator in that fraction is done. We're good to go there. So now I'm trying to find if there is a perfect fourth that creates 16. If necessary, as we've done with our previous problems with this, you can use the prime factorization using our table method that we have here or any other method that you'd like to find that. I'm noticing that I have 2 to the 4th power, so that 16 is the equivalent of saying 2 to the 4th power. So the 4th root of 2 to the 4th power is just going to be 2. At this point in time, I'm now done. If you at the top of your head know that the 4th root of 2 is 16, you don't necessarily need to do all of this process out and write it out for yourself, but just noting this as a bit of a refresher from previous sections that all of that stuff is fully eligible to be showing up again here. Looking at example 2, we're going to basically do the same thing we did with example 1, and that we're looking to rewrite this thing into one of our 4 different forms that we have for rational exponents, and then solve this for our final answer. Again, I'm noting that the numerator is 1, so everything is going to be raised to the first power, so I'm going to jump right to using the denominator as the index of the radical to say I'm going to have the 4th root of negative 16. This negative is inside of the set of parentheses, and that set of parentheses is all being raised to a power, so we are including that negative inside the radicand here. Now it should be noted, I'm taking the 4th root, meaning an even index root of a radicand. Can I take the even index root of a negative radicand, remembering back to our previous material? And no, we cannot. So because I cannot take an even indexed radical root of a negative radicand, I therefore would not get any real solution showing up from this. So in this regard, even after doing this rewrite, I'm going to have no solution. Depending on the book or the instructor that you are working with, they may also want you to write out instead, no real solution. But either way, I'm not going to be able to get a real answer showing up out of this problem. And it should be one of these 2 that should work for your class. Make sure you're clarifying that with your instructor or comparing this with the answer key that you've been provided to see which specific one your class is looking for. Looking at example 3, we have been given something that's already in one of those rewritten forms that we were given earlier on in our notes. So if we wanted to do a slight back step from this, we would say that this is the equivalent of saying, whoops, this thing would work for me. There we go. 3 to the 4/3 power. 3 is being raised to the 4th power, so that's going to be the numerator. And then I still have this 1/3 here, so it's going to still stay as a 3 in the denominator down below. It's at this point in time that now we can determine how we do or don't want to rewrite this thing. Now, I'm going to stay with the form that we were given originally, but I'm going to rewrite it into actually showing the radical that's given to us here. So when I do that rewrite, I get the cube root of 3 to the 4th power. Now from here, I have an index of 3, meaning I'm looking for a perfect 3 to the 3rd power showing up in this radicand. I do actually have that, as 3 to the 4th power is the same as saying 3 times 3 times 3 times 3. Right here I have a perfect cube. The cube root of a perfect cube is just the thing that I'm taking the cube root of. So I'm going to have 3 out front. The cube root of, I have this leftover 3 in there, can't drop that. It's going to stay in. So this is going to make my final answer 3 times the cube root of 3. So I just wanted to note at the very beginning how we could rewrite it into our kind of general form if need be, and then if we wanted to, you could write it into a different form after that if that's something that stands out and jumps out to you to do. You don't have to, but just noting that this is an option that you can use as you're going through these problems. Our fourth example is where we start to see the negative exponent show up. And so for this example, I say we start with dealing with that right off the bat. Now remembering our property for a negative exponent, that says it takes the base, whatever that is, and it moves it from where it is in the fraction to the opposite spot. So this 25 is currently in the numerator of a fraction. So I need to move it to the denominator of a fraction, which means this thing is going to get rewritten as 25 to the 1 over 25 to the 3 over 2 power. From here, I can do a rewrite now. I have those 4 different forms that I can write this thing in and do with them as I see fit. Any of those will work, and it's your choice on which one you would like to use. So if you want to follow the method that I'm using, if you want to use a different one, go for it. I'm looking at this and noticing that 25 is a perfect square. I'm also noticing that the denominator here says that I'm going to be taking the square root of something. The numerator says I'm going to be raising that base to the 3rd power. So if I'm thinking about that, what if I take the square root of 25 first? I'm going to get a reasonably small-ish number, and then I raise that thing to the 3rd power. That might be easier than raising 25 to the 3rd power and then taking the square root of it. It's just a matter of how big or small we want these numbers to be as we're working through them. So with that plan written out, let's go ahead and actually write it out for ourselves. So I take the square root of 25 and raise it to the 3rd power. This is the equivalent of the bottom left option that we have for rewriting these forms. From here, the square root of 25 is going to give us 5. So I now have 5 to the 3rd power. And then 5 to the 3rd power, that's going to give me 125. So I get 1 over 125 as my final answer. As you're going through this, if you have weird numbers being raised to higher powers or anything like that, you're more than welcome to use a calculator to help you out and assist you with getting to the final answer from there. If 5 to the 3rd power is one of those such examples, then by all means do it. Use a calculator. With example 5, we start to see that our different rules and properties for exponents start to come into play, and we are going to have fractions showing up with those as well. So looking at this one, we're noticing that we have 2 bases that are the same and they are multiplying together. This tells me I'm going to be using the product rule. So if the bases are the same and multiplying, then that means the exponents are going to add together. So this is the same as saying x to the 2/5 plus 1/5 power here. 2/5 plus 1/5, the numerators can add together because the denominators are the same. And I'm going to get to a final answer of x to the 3/5 power. Make sure you are correctly identifying which property or rule for exponents you are using before you dive into just adding, subtracting, multiplying, or dividing exponents together. There's a lot of subtle room for error with those, so double checking that in your notes goes a really long way. Looking at example 6 here, we once again have our different rules and properties of exponents at fair game for us to use here. For this one, we are looking at a product raised to a power rule. We have 2 things inside of a set of parentheses that are multiplying together, which means we have a product going on there. And we have that product being raised to a power here. So I can write this out as using the product to a power rule. You have a few ways you can write this out for yourself. I'm going to go through one of them. Actually, I'll go through a couple of them. Why not? We've got some space here. So a couple ways you can go through and think on this. Now, if you want to break this down into smaller parts and deal with each of these exponents and what's going to happen with them with regards to this 1/3, you can do that individually. So what that looks like is saying a to the 9th to the 3rd power times b to the 12th to the 3rd power. From here, we are applying the power rule, which states that if the exponent, or if an exponent, should say, whoops, use the right pen here, the highlighter, there it is. If I have an exponent, a to the 9th, raised to a power, 1/3, then those two exponents are going to multiply together. So I get a to the 9 times 1/3 power. And the same thing with b, I get b to the 12th times 1/3 power. We simplify each of those exponents down, and I'm getting a to the 3rd times b to the 4th power here. So this is one way you can go through and write this out for yourself. Again, if you have a product raised to a power. I'll also show just a parallel with this as another option as well. If you're looking at this and you're noticing, well, hold on, this is going to effectively multiply to 9 and multiply to the 12, then I can just jump right to a to the 3rd power times b to the 4th power, and we don't have to do all of these intermediate steps as necessary. Just make sure that you are applying this rule if and only if you have a product raised to a power. If there is any addition or subtraction going on inside of this set of parentheses, the product to a power rule does not apply and we cannot use it at all. So now we get to a few examples where we have several different things going on and several different options for how we want to start and go through these problems. With number 7, we're noticing that we have negative exponents showing up in here. We have multiplication of things showing up in here. With this fraction bar, that implies that there's going to be division that's showing up here as well. So there's a lot of potential ways that we could start and go through this problem. My recommendation, if you're unsure about which thing to use at the very beginning of the problem, I think it's worthwhile to note the potential rules and properties that we could be using here. So we have the product rule that could show up. We have the quotient rule. We also have the negative exponent rule showing up. So I'm just going to say negative exponents. Now, any and all of these rules and properties would be great things to start off doing with this problem. It's your choice on which one you would like to use, but really we just need to pick one and commit to it. For me personally, I like dealing with negative exponents first because I think they can get a little annoying. Keeping track of when am I going to apply that negative, how is that going to apply to everything around it. So I like getting rid of those first. Again, you're not forced to do that. It's just one of the things that I found that works best for me. So I have a negative exponent in the numerator spot. I have a negative exponent in the denominator spot. Remember that all the negative exponent does is it takes the base and it flips it to go to the opposite part of the fraction. It's the only thing it changes. So when I rewrite this, the only change that's happening is I'm now going to have x to the 2/3 power times x to the 7/3 power in the numerator spot. And I'm going to have x to the 5/3 power in the denominator spot. I just changed my negative exponent here and here, and just changed where they were in the fraction. So now the negative exponents we have here, done, taken care of. So what's the next thing that we could do? Well, we've got the product rule, we've got the quotient rule showing up. It's your choice on which one you would like to do first. I'm going to go with the product rule. I'm going to work with the numerator first. The product rule says if the bases are the same and multiplying together, then the exponents are going to be adding together. So my numerator is going to become x to the 2/3 plus 7/3 power. That's all over x to the 5/3. Move this up here just a bit. When I simplify that numerator down, I'm adding the 2/3 plus 7/3 together in the exponent spot. And I'm going to get x to the 9/3 showing up over x to the 5/3 there. At this point in time, we can look at this and notice, all right, well, I've got the product rule taken care of. I now have the quotient rule showing up. That's the only thing that's left. So I'm going to deal with the division that's showing up right here. The quotient rule states if two things have the same base and they are dividing, that the exponents are going to subtract from one another. So that means I have x to the 9/3 minus 5/3 power. When I do that subtraction, that's going to give me x to the 4/3 power. We've noticed here with our little check boxes that we have, our checklist, all of our potential steps are done and taken care of, and now I get to my final answer. So when you're going through problems like these and you're not sure where to start, I think it's a pretty good idea to take a minute, 30 seconds or so, just to write out what are the potential rules and properties that you could apply in a problem, and then from there determine which one you want to start with and then go with next, and so on and so forth as you see fit. All right, and now we have number 8, final example with this. Similar to what we did with number 7, I think it's worthwhile to write down the potential rules and properties that we could use here, because we have a lot of options at our disposal. So we have the product rule showing up, we have the quotient rule showing up, and then we also have negative exponents showing up. I'm going to shorthand exponent here. Get the same idea across there. In example 7, we started off with the negative exponents to get through this problem. So we started with dealing with these. Let's go with this in a different order, just for the sake of seeing that we can do it in different ways to get to our answer. So instead, I'm going to start with the product rule. In the numerator of this fraction, I have a to the 3rd power times a to the negative 1/4 power. The product rule states that if two things have the same base and they are multiplying, that the exponents will add together. So I get a to the 3/4 plus negative 1/4 power, all divided by a to the negative 6/4 power. Simplify that numerator down, and we get a to the 2/4 power. Now you might be looking at this and thinking, well, hold on, I can simplify and kind of reduce these fractions down as I'm looking at this problem. And yes, you could if you would like to, but if you're going to potentially use the quotient rule later on, and or you might have the product rule showing up, that means you're going to have to add and subtract fractions together. At the very beginning of this problem, all of these fractions have the same denominator. So if I need to add or subtract anything together, all of that denominator prerequisite steps that we need is already done for us. So we don't have to worry about that at this point in time. So from here, we've done the product rule. Excellent. Let's work with the quotient rule next. So the quotient rule states that if two things are dividing and they have the same base, that's the same as saying the exponents are going to subtract from one another. So I have a to the 2/4 minus negative 6/4. We keep that denominator as a negative inside here, and then we'll deal with this double sign stuff showing up here shortly. So I rewrite that, because I don't like double signs, I always get them confused, as saying 2 to the 4th power plus or a to the 2 over 4 plus 6 over 4 power. Now 2 over 4 plus 6 over 4, that's going to give me a to the 8 over 4th power, and 8 over 4, now that I have everything else fully canceled out and worked out, I get a to the 2nd power. So it turns out that in the process of doing that, I actually didn't need to work with the negative exponents at all. They happen to cancel out and get taken care of in the rest of the problem. There's no guarantee that that is always going to happen with these problems. It just so happens to be the case in this problem that ended up happening. So, big thing to take away from examples 8 and 7 is that you have multiple choices on how you want to start these problems. It's just a matter of which one do you want to choose to begin with, and then just committing to that and doing these in very small, very controlled parts along the way. I think that tends to make these a little bit easier. To recap the 9.8 information that we covered with rational exponents, make sure that you are correctly identifying the base of each exponent that you are working with in a problem. That does influence what we are and aren't going to be able to do with these. We have our rules and products, or rules and properties, I should say, for exponents. Make sure you have those written down for yourself if necessary. I think they quite handy to have a little cheat sheet of all of them right here if you can possibly get that. We then also had our main bulk of the material, which is working with rational exponents or fraction exponents. Remember, the numerator raises something to a power. It's higher in the fraction. It's going to make the number larger in that regard. The denominator tells us the index of the root, or it tells us to take the nth root of the base. It's below in the fraction, so it's going to bring our answer down in value. We also had our 4 ways of going through and writing out these expressions that have rational exponents in them. You're welcome to use any of them as you see fit and rewrite them accordingly. And we had our 8 examples show up here as well. I'm going to scroll down here and give you some practice problems if you would like to work through these. Again, I'd recommend pausing the video here if you'd like to give these a try on your own before going through and looking at the answer key. We'll scroll down and get the answers now. So as you're going through these, hopefully you took some time to write out the potential processes and potential rules and properties you could be applying as you went through these examples. Again, I think that helps keep everything in line and organize our thoughts and potential ways we could go through and solve a problem, versus look at something as one big, terrible example and try to do it all at once. I tend to find that works a bit less effectively with these types of problems. But beyond that, that's everything for our 9.8 material.